Okay, did you pull the latest from master? Okay. You can tell Claude to do it for you. He knows how to run all that stuff. Just tell him that you want to pull the latest from master into your branch. And then share your screen and we'll kind of go through some of the stuff. So what I did, the software is kind of shitty, like the problem with it is I've been doing all my work in IT still kind of, we just have some of these specialty projects where I'm starting to use the software where, we don't have an equivalent in IP. So the motif thing, like some of these things aren't even possible in IP. For example, there's no way that you're going to be able to deal with 6,000 wells in IP. There's a hard cutoff on 2,000 wells. That's the maximum that it allows you to load into memory. So even if we had the modules, it's still, anyways, the point is, I haven't really run through a lot of these things yet. So I'm finding lots and lots of bugs as I go along. So, I'm testing stuff and just to kind of give you, take you along for the ride so you learn from it the same way that I am. What I'm doing, like, for example, I'm testing this clustering code, right? And, one of the things you can have the AI do is, I have it build a test harness to like unit test, not really unit test, but module level testing of the module. And then we know, for example, that we've got, industry standard workups of some of these things in packages like scikit-learn or, um, whatever else Python has. So what you can do is you can run tests against both using the exact same data and then compare the results, right, to make sure that the outputs are the same. So there's like terms for this in software engineering, but I'm kind of benchmarking it against known standards so that we don't have to guess. And if there's problems, then we can start to figure out where they are. Some of this stuff, obviously, there's no Python standard like mineral solver. So, we could have serious bugs inside of that thing yet. And the only way that we're going to find them is just by either creating synthetic cases, mathematical cases that are going to yield a specific output, and then run that through the system and see what happens. Or we benchmark it against, existing interpretations. So, for example, if we take a well from IP, just load whatever log data, like pick a well, any well, grab something from the public database, and then run a mineral solver run on it where all the endpoints are fixed, the values that we know. So don't make it complicated, make it simple, like clays 2.5 density, 0.5, whatever, run it through, grab the result, put the exact same inputs in our solver, run it, compare it. And some of the things like the solver is not prepared as a generic module like IP's is. Ours is specific to unconventionals. It's got a lot of things baked in that I'm going to have to change before I can get to that point. But that's not a primary focus. The primary focus right now is getting all this work for Diamondback done for Calvin, because there's a deadline on it, right? This stuff is being done for the interns, and they need to be able to present it when their internship is over, which is like in a month. So, yeah. So, but a lot of the pieces are already there. and they're working. Like the clustering stuff, I'm pretty confident about that now. The motif stuff, we're kind of flying by night on that one with on instruments, you know. And we're just gonna have to go with it. But they already made some maps, the preliminary work, and said it looks pretty good. So, but anyways, what I want to do with you today is share your screen. How you feeling, by the way? You feeling any mm, weak? Yeah, if you need to take some time off or whatever too. I mean, I'm not feeling well either. Uh, I'm just weak, not sleeping well. I got similar sinus problems and all this going on. Yeah, sinuses are swollen. That's why I've been using this Flonase and taking an antihistamine to try to calm it down. But it's definitely COVID, I think. I did a test tonight. It came back negative, but I kind of expected that because it's not a high enough viral load. Like I've had COVID so many times now. I think this is like the eighth time or something. Yeah, and I had very similar infection, just like this one. Same symptoms back in March in Australia, and John's kids had it, and John had it. Like everyone did it. So it seems to be like one of these super contagious strains, but it's not that severe, but it lingers. So the last one, just to give you a timeline, uh, I was in Australia for 2 weeks. Came in, was fine for a day or two, got sick right away, and I was sick for like 7 or 8 days. Yeah, and it wasn't like really bad. I never had a fever or any body aches or anything like that, but just weak and not a whole lot of energy and the constant. I was sneezing like crazy, and I had tons of post nasal drip, just wouldn't stop. I was blowing my nose like 100 times a day. Anyway, so what we're going to do today is we got this database with 6,000 wells in it now, and what we need to do is run that motif model. We have to load the additional tops, and then figure out. We'll have to do some bulk curve renaming, and then run it through to build the model on the wells that have tops picked in it, and then we'll just run the motif model on all the wells, and then there's a utility in the software to take the tops that come out of that and turn them into a numerical curve. So then we'll do that, and then we'll drop all the last files out for those guys to map. But what we need to do along the way is create a report and a presentation with what we did, so they have, we have documented evidence of it. And the other thing that I'm sort of bad at is keeping all this stuff bookkeeping wise. Like once we run the model, we need to save it. So once it's saved, um we can rerun it, reload it, or whatever, so we don't lose that trained model, all those sort of things. It may be a function of the number of wells in the database. When you got a lot of wells, it does an integrity check on all the files before it opens the database to see if anything has been corrupted. That takes a little bit of time, maybe about a minute or so. But it should tell you what it's doing when it's doing it. The other thing to make sure of too, yes, he's doing the integrity check on all those wells. So now it's saying, oh, we got corrupt wells. Uh, well, yeah, cancel because you probably, did you finish loading the database before you opened it? Unzipping it or whatever? Yeah, that's why they're corrupt. So close the thing and then once it's finished extracting, then we reopen it. I wouldn't, I mean, the correct answer is yes, but I think for right now, let's worry about that later. Let's just get the interpretations halfway decent first, and then we'll just make a spreadsheet and just flag the wells that have problems in them. And what the problem is, and we can come back to it later. Because that's the sort of workflow that unfortunately we're gonna have here is we just don't have enough time to do everything, you know? So even if it's off depth a little bit, that's fine. Like we have something to work with for the ML stuff, and then later on we can come back and yeah, it's because there's 6,000 wells. Guess the other thing to make sure too is if you right click on your little battery icon down there in the taskbar and you go to, yeah, well, just right click on it. Yeah, okay, so you got it on best performance. Like sometimes there's weird, there we go. So now you should be able to go to the, we'll need to go to, I think it's the tools menu. And then, oh, wait a minute. Data menu. The data menu on the left, yeah, and then import formation tops. And now we need that file that I sent you in the chat. I don't even know if that's an Excel file or if it's a CSV already or. Okay. And then. So for the API, select that. And pick UWI, yep. Formation is gonna be pick name. Top depth is MD. And base depth, just leave it as none, because they didn't give us a base depth. And then infer base steps from the next formation. And allow repeated formation names, I think. And import, yeah. Well, hold on a second before you import that. Let me look at that file because I think he's got like a lot of tops and stuff in here that we don't care about. Author WBF. Okay, so these are all his picks. Yeah, so instead of import for the top set name, call it Weston. So that we know that they're his picks in specific. Or I guess you already did it, right? All right. Now, could be. I mean, the worst thing that can happen is that you max out your memory and then you start swapping the disk. So if that happens, that really slows things down a lot because it's got to write to the hard drive. You don't want to do that, but if you're not maxed out yet, you're 90% or whatever. So and one thing you can install on your computer if you want to go grab it, it's called Rainmeter. It's like a little app that's got skins that show you the disk usage and the memory usage and the CPU usage, like on a thing on the top, kind of like Linux, so that you can see instead of having to use that shitty task manager. But if you go to Google, it's called Rainmeter. Yep. I'm trying to open that same database on my computer and it's doing the same thing. It's taken quite a while to. Mhm. I don't know what they're doing. I doubt it. They're probably just using IP at the moment, which is fine for the work that they're doing. I mean, the mineral inversion thing, again, I'm just trying to get ahead of the workload that's coming, right? We're going to end up probably using that pretty heavily to help drive some changes in the petrophysical model coming up here after asset reviews are done, that people have time to discuss these things. But for the moment, I just wanted to get it built so that we'll have it when we need it. So I think what you can do is you can go to that thing. Yeah, and there's like yeah, close that thing out. Go to the rain meter configuration again. If you go to the, yeah, so it's that thing on the left that you got over there. You see that in the lower left? It's got this CPU memory. So you can configure these things, like I got mine on the top, so it lays it out horizontally instead of vertically. I think you can do that widgets performance combo thing there. Yeah, if you go back to the rain meter configuration and then go to Win10 widgets. Yeah, go to the Win10 widgets performance combo. Yeah, and then do I think it is edit or settings, maybe go to settings. What's in settings? Yeah, go to that one and then settings. Position. Uh, you might have to go into the edit skin thing. Edit skin. Yeah, so I don't know. You'll figure it out, but you can get it. So I had to mess around with it till I could get it to where it's you know, across the top, easier to read, but then you can see what's going on. So like if you see your disk start maxing out, then and the memory's maxed out, then it's swapping the disk and then you got a problem, right? So you got to free up memory somewhere. Yeah. So here, I'll just share my screen real quick while we're waiting for all this stuff to go down. Um, so same database. You come to that sequence motifs thing. And everything takes a while to load because I think it's reading a lot of the well names and stuff. It's got to go out there and make 6,000 reads. I don't know. I need to change some of the code to fix that so that we have a list that doesn't require all of those reads. That's what freezes this thing up. 6,000 wells. This is the first time I tested this software with this many wells. So yeah, like it's got to draw the check boxes and stuff in here for each well. So it just kills it. Like the sheer number of controls that it has to draw. I mean, I haven't even done anything and I'm already maxed out on memory almost. So it may be a problem. See, like all these things down here, it's got to draw all these controls. But anyways, the thing I wanted to show you is over here on the right. There, I implemented your thing. So it says, add a smooth copy of gamma rays and extra source curve. And then it calculates all the attributes from it. So you can check that and then give it a window size. And then, yeah, with either a median or a mean smoothing filter on it. You can just change the window size. And then when you train it, it'll use that. So I'll just try running this to see what happens. It's probably going to blow up. We're probably going to have to make some changes to the program before it's going to work properly, just to deal with the fact that there's so many wells. Like I say, my memory's already maxed out, so I know what's going to happen when I go to run this. It's just going to. But one of the other things that we have to do is run this. I've got like a multi-well batch curve mapper. And what it'll do is it'll go into the new wells that we loaded 'cause it just got raw, right? And you're gonna have to map like this PGSR and the P neutron to gamma ray and neutron, so it's the same mnemonics like I've got here. And then we'll just run it, it'll fit out all the stuff, but for the moment, I think we're probably dead in the water just because everything is so slow. But yeah, I need to figure out. Well, what's killing it, I'll be honest with you, right, is this is the first time that I've worked with this UI. Just came out from Microsoft at the beginning of the year in November of 2025. It's called WinUI 3. And like in the old IDEs, when you build controls and stuff, they aren't very sophisticated. They're pretty simple. And they were written a long time ago and very robust, like they're efficient, So if you create 5,000 controls, it's no big deal. But with this thing, whenever you create like these checkboxes, like there's 2 checkboxes for each line item, and like these things, they're designed for use. Like this whole UI kit is designed as a multi-platform kit. So like, if you look at the software, the way that it's being built, it's kind of like tablet friendly, where people are using touch screens and stuff like that, and the controls respond to those things. They're not designed just for a computer where you're clicking around with a mouse. And because of that, they just carry a lot of extra shit with them. So they're really slow. Like this is one of the worst problems with this is the dev package. One of the best things about it is that like if I open up a log plot or whatever, the log plot that's being used, the controls behind this to render the graphics are GPU accelerated. So it's using the GPU to draw, which means it's really fast rendering, which is great. But that's a log plot control. These sort of things, which normally would not be a problem, are a problem just because there's 6,000 checkboxes. Even the response time on this is so slow, just trying to drag it. So we got to find a solution for that. If I close that window, it's just like unloading all those controls and everything. I don't know if it's going to run a garbage collection on here, but the program hasn't even done anything. We've run nothing. All we did was load the database. But we didn't even load everything in the memory, and I'm already using 9 gigabytes of process memory and another 8 gigabytes of managed memory. And the actual curve data is only 1.6 gigs, So a lot of it's got to do with that map control, some other things, and how it loads. And then obviously garbage collection, like when these objects aren't being referenced, they need to go away to free up memory, and that's not happening right now either. So anyway, instead of continuing to struggle with this, I'll start working on some fixes to deal with the 6,000 well problem to make the software faster, and in the interim, just let that formation things load, and we'll come back to this some other time. Come back to this later. Okay. All right. We'll see you here at the other meeting. Talk to you later, okay? All right, bye.